Hi everyone, Kyle again, and this review video will go over finding the slope-intercept equation of a line given two different points. Firstly, remember that the slope-intercept form of the equation of a line is y equals mx plus b, with m being the slope and b being the y-intercept. Now, our goal is to find the equation of a line given 2 points, and for the sake of generalization, we'll say that those 2 points are at the coordinates x1, y1, and x2, y2. In order to find the equation, we'll want to solve for the values of m and b, and luckily for us, we can easily find m. If you recall from the notes video on finding the slope of a line without graphing, the slope of a line given 2 points is the difference of the y-coordinates, or y2 minus y1, divided by the difference of the x-coordinates, or x2 minus x1. After you found the slope, all that you've got left to find is the y-intercept. To do that, you're going to have to borrow one of the points that you're given and use its coordinates. It's a common practice in algebra problems where you'll use the information that you have to solve for a different variable first. In this case, take the y equals mx plus b form, substitute the slope that you calculated for m, and substitute the x and y coordinates of a given point into x and y respectively. This will allow you to algebraically solve for b, and giving you the slope-intercept equation of the line after you substitute the m and b values back into the slope-intercept form. Now, with this process in mind, let's move to the best part of these videos, practice problems. Pause the video here and try these problems for yourself first. All right, let's look at number 1. We're given 2 points at negative 530 and 12, negative 21. With these points, let's try to first solve for the slope. We'll divide the difference of the y-coordinates, or negative 21 minus 30, which equals negative 51, by the difference of the x-coordinates, 12 minus negative 5, which equals 17, and this simplifies to negative 3. Next, we'll need to solve for our b value. I'll just randomly choose the point negative 530 to substitute into the equation, but you can choose either point, whichever you feel is easier to calculate with. We have y equals negative 3x plus b, so I'll substitute negative 5 for x and 30 for y, giving us 30 equals negative 3 times negative 5 plus b. That'll simplify to 30 equals 15 plus b, and subtracting 15 from both sides, we'll get 15 equals b. Finally, we'll substitute in our m and b values back into the slope-intercept form to get our final equation, y equals negative 3x plus 15. If we ever want to double check our answers, then we can always graph the equation and just double check that the line goes through both of the given points in the problem. Now let's try a second problem. This one gives us the points 3, 5, and 3, negative 1. Those of you with a keen eye may have noticed that the x-coordinates here are the same, but we'll see if that causes a problem in a second. So let's try to find the slope first. We'll again divide the difference of the y-coordinates, or negative 6, by the difference of the x-coordinates, 0. It gives us a slope of undefined. Well, we can't divide by 0, so how do we find the slope? Well, quite simply, we can't. In fact, if we graph the 2 points and draw the line between them, we'll get a vertical line, and we can see that this line doesn't have a y-intercept either. In this case, we'll kind of have to rely on the properties of graphs that we have seen before. If you do remember that if you've encountered graphs that are just vertical lines, you might remember that the equations look like x equals something. Well, the graph of the equation is the set of points that satisfy that equation, and the 2 points we're given have an x-coordinate of 3, so the equation of this line must be x equals 3, as these points both satisfy that equation. Do be careful not to make the mistake of dividing by 0 as equaling to 0, as this could mess up your calculations. And in this case, if you substitute the coordinates into the equation, it would give you 2 different y-intercepts, or b values, and 2 different equations instead of one line containing both points. And now for the most dreaded of problems, a word problem. Pause again and try to solve for yourself, as dreadful as they may be. Just take it step by step. All right, let's do it together now. We are told that the y is the amount of money and x is the number of years after opening the bank account. Next, we are given 2 data points, 8 years after opening with $230 and 15 years after opening with $300. That translates to the points 8,230 and 15,300. Next, we are told that the growth is linear, simply meaning or assuring us that the equation and the graph modeling the growth of money in the bank account can be modeled as a straight line. Essentially, we can use y equals mx plus b. Last is what the problem is actually asking. How much money is there after 20 years, or in terms of our variables, what is y when x equals 20? Well, we have 2 points, so let's first find the slope. Find the difference in the y values, which turns out to be 70, and the difference in the x values, which turns out to be 7, divide, and we'll get a nice even 10 as our slope. Next, we'll find the y-intercept by substituting one of these points. I'll go with 15,300 this time. Again, either point works just fine. Solve for b, and we'll find that b equals 150, allowing us to put together the final equation of y equals 10x plus 150. Finally, we want to know what y is when x equals 20. So naturally, we'll substitute 20 for x and solve for y. That'll give us eventually our answer of $350. I hope this video has been helpful in helping you to find the slope-intercept equation given 2 points on a line, and I wish you the best of luck. Have fun and ask questions if you have any.